Hello, class. I wanted to go over the week 4 formative assessment to give you a tutorial on what you'll be working on this week. And so for this formative assessment, you will be working with balancing chemical equations and also doing calculations based on those balanced chemical equations. So in this first part, you're talking about balanced chemical equations. And when we look at a reaction, on the left side of the reaction, those are known as the reactants. On the right side are known as the products. And the purpose of balancing is to obey the law of conservation of mass. That's one of the laws you'll be, excuse me, learning this week. And so if we look at this first example, N2 plus H2, those are your two reactants. NH3 would be your products. Remember, products are on the right, reactants are on the left. The arrow is what separates the two. Okay. And so when we're talking about balancing, we are changing, excuse me, or we are adding what are called coefficients to the beginning of the different substances within a chemical reaction. And that is so that we're obeying the law of conservation of matter. So, one way you can think of this is this chemical reaction is like a recipe. And so the numbers that we add are the measurements that when we add them together, it produces a certain number of products. Okay. And so when we're looking at balancing and go through the steps that are given here in the handout, but I want to give you just like a brief overview. So if we look at these substances that we have carbon, C for carbon, H for hydrogen, O for oxygen, and you should have the same elements on the product side as well. The numbers that are after that are what we call subscripts, those are the number of atoms of each element. And so let's scroll down a little further. For carbon on the reactant side, there's one, because anytime you have no number written, no visible number, it's understood to be one. So there's one carbon. We look at hydrogen, we have four, so it's four hydrogen. If we look at oxygen, we have two, so two oxygen. Now we're going to look at the product side. Again, we have one carbon. We have now two hydrogens, so we put two. And then oxygen is in two different places on the product side. It's a two here after for CO2, and then a one here for H2O. If there's a plus sign between where your two elements are listed, you're going to add them up. So 2 plus 1 is going to give us 3 oxygen. The next thing we want to know is this reaction as it's written balanced? And if these numbers are the same as these numbers, so if carbon's the same, hydrogen's the same, and oxygen are the same, so they all have to be the same in order for the reaction to balance. If at least one element is not balanced, that means the entire reaction is not balanced. And so our goal now is to balance it. And so, what we are looking at, first of all, before we get to start balancing, let's see what is not balanced. So, carbon, we have one on both sides, so carbon is balanced. Hydrogen, we have four on the reactant side, two on the product side, so it's not balanced. Oxygen is two on the reactant side, three on the product side, so it's not balanced. So, let's start with our hydrogen. So, we have four on the reactant side, two on the product side. So if we put a coefficient of two, okay, anytime you're adding coefficients to balance it, you always put it at the beginning of the compound because it is going to represent everything in that compound. And so we put a 2 in front of H2O. When we do that, the coefficient times the subscript gives us the total number of atoms of hydrogen. So 2 times 2 will give us 4 for hydrogen. So now hydrogen is balanced on both sides. But remember, I said that the 2 not only represents the hydrogen, but also the oxygen. So 2 times the subscript of 1 gives us 2 oxygen here. But remember, we have 2 oxygen for CO2. So the 2 here in H2O, the 2 here for CO2 gives us total of 4 oxygen on the product side. We still have 2 oxygen on the reactant side, so we need a coefficient for our oxygen. And that is why this 2 is written here. So 2 times 2, remember the coefficient times the subscript, will give us 4 oxygen on the reactant side. In the previous portion, we got 4 oxygen on the product side. So now you see the number of carbons are the same, the number of hydrogens are the same, and the number of oxygen are the same. And so we say that this reaction is balanced. And then there's some other examples that are listed here, but I'm gonna move forward. All right. So counting atoms and thinking deeper. Okay, so a few things that I do want to introduce here in part 6 is the S and that G. S represents that this substance is a solid. G represents that this substance is a gas. If you saw an L, that would represent a liquid. And if you saw AQ, that means it's aqueous. Okay. And so first, they just wanted you to list the reactants and the products. So what does the arrow represent? You're going to put that there. How many atoms of each element are on the reactants, as well as the product side. So remember, we looked at the number of atoms when we were looking at this example here. When it's unbalanced, like we got at the beginning, then you're just looking at the subscripts for each element on the reactant side and the product side. And so that's how you will do this portion of the assignment. Okay. And then the same thing for reaction 2. Now we want to calculate the molecules and the moles. Once your reaction has balanced, then you are using those numbers to represent the number of molecules as well as the number of moles. So that's what the coefficients represent. And so if we're looking at H2O, in that first reaction, we have no number written for the coefficient. So if there's no number written, then it's understood to be 1. So that's 1 molecule of H2O for 1 molecule of H2. Okay, so that's all they're asking for in that first one. But when you get to something like part C, for number 2, it says how many molecules of CO2 are produced when 2 molecules of O2 are consumed. So if we look at O2, it said there's not a coefficient written, so that means it's 1. And then the coefficient for CO2 is 2. So for every 1 molecule of O2, we get 2 molecules of CO2. So if we had 2 molecules of O2, that means it would double the amount of CO2. So that would be 4 molecules of our CO2. Okay. And so this balanced equation gives you the relationship. And then if you want to change that, you see what the change is and you make that same change. Okay. So let's look at another example. All right, it says how many moles of CuO react in order to produce 12 moles of Cu. All right, so if we look at Cu and CuO for the first reaction, there's 1 mole of Cu for every 1 mole of CuO. So if we have 12 moles of Cu, then it would be 12 moles of CuO. Okay, and so that's how you want to go through and do this particular reaction, as well as answer these questions. One I want to point out is number 8. And it says we have 100 grams of CuO are consumed in reaction 1. Does that tell you that 100 grams of Cu are formed? And so when we're looking at balanced chemical equations, it tells you differences between moles and also molecules, but it doesn't account for grams. So if you think back at the periodic table, the mass number tells you the number of grams per mole. And so if we're comparing grams of one substance to grams of another substance, then we have to take into consideration the atomic mass for copper and the molar mass for copper 2 oxide, CuO. And so you can't just say that their number of grams are the same because their number of moles are the same. Okay? So keep that in mind when you're answering those questions. Part 8 deals with counting charges. And so when we're talking about counting charges, we're looking at the visible charges on the substances. And so we want the total charge on the reactant side to equal to the total charge on the product side. So let's look at number 1 to give you an example, and then the others you can go through. For number 1, you have a plus charge here. Excuse me. You have a plus charge, and then you have a negative charge. So if we add a plus 1 to a negative 1, that's going to add up to 0. On the product side, it's a compound, and there's no visible charges here. And so if you don't see a visible charge, then the charge is 0. And so we have a 0 on the reactant side, 0 on the product side, so the charges are balanced. One thing I want to give you a heads up on, if you have a coefficient, like you see here for number 3, and you have a charge, so 3 and negative 1, that means you're going to multiply the charge times that coefficient. Okay, so keep that in mind as you're going through and doing those calculations and answering the questions. I think this is the last part, which is part 9. It deals with applications. So it is basically giving you an opportunity to do some balancing of your equations and getting the final balance for your reaction. If you have questions, as always, on this lab or any assignments that you have for week 4, make sure that you reach out to me. Have an awesome week. Bye bye.